Solution? Well, you know you're going to have to factor this eventually, and it's actually pretty easy to factor, so we might as well do it now. We pull out a greatest common factor, and that would be a negative x squared. I like to pull out the negative guy to make my first term positive. And that's going to leave x to the second power, and then minus 196. But 196 is actually a perfect square, so we can rewrite this as x squared minus 14 squared. Now we're going to use the formula that says a squared minus b squared equals a plus b times a minus b. Using that formula here, this is equal to negative x to the second parenthesis times x plus 14 times x minus 14. Okay, that's f of x. Oops, I'm continuing the solution. I didn't need to write it again. Now I'm going to look at note number 86. How to graph of polynomial function. First we look for symmetries, f of negative x. Well, let's see, we've got a negative parenthesis, negative x to the fourth, plus 196 parenthesis, negative x to the second. Now you know whenever you have an even power, it will not change the sign. So this turns out to be negative x to the fourth, plus 196x to the second, and that's the same as f of x. So we just found that f of negative x is the same as f of x. And that tells us something about the symmetry. Specifically, that we will have symmetry with the y-axis. So if you fold it on the y-axis, you'll see a similar picture on both sides. So keep that in mind. That will be something we can use later. Let's go to step 2. We're going to find the real zeros. Those are the x-intercepts. Well, we already have it factored, so we just set each of the factors equal to 0 and solve. Negative x squared equals 0, together with x plus 14 equals 0, together with x minus 14 equals 0. We take each of the factors and set them equal to 0. Here we'll multiply both sides by a negative sign, or negative 1, and get x squared equals 0, and then take plus or minus the square root, we get x equals 0. Now that gives us the following x-intercept. It gives us the x-intercept 0, 0, with multiplicity 2, because it was the second power. Here we get x equals negative 14, so that gives us the x-intercept negative 14, 0, and that one has multiplicity 1. And finally, this last guy, he gives us x equals positive 14, so that gives us the x-intercept, the ordered pair 14, 0, with multiplicity 1 also. Step 3, we look at the x-intercept behavior. So at the x-intercept, at the first one, 0, 0, we have even multiplicity, so that says we get a kiss. For the second dude, it's an odd multiplicity because it's multiplicity 1. That means it's a cross. And for the last one, we have the odd multiplicity, so that's also a cross. Remember, the multiplicity is a power on the factor that contains the root. So when I said that these last two had odd multiplicities, I meant if you look at the factorization up at the top, before we wrote note 86, the x plus 14 factor and the x minus 14 factor, their powers were the first power, so they had 1 for their multiplicity, which is odd. Now let's look at the end behavior. We notice that this is a degree 4, which is even. And the lead coefficient, the number multiplying the highest power, is a negative 1. So that's negative. So we put those together. An even multiplicity, even degree, with a negative lead coefficient means the end behavior will look like this. Okay, keep that in mind. That's what we expect to see at the end. Let's go to step 5. Well, the y-intercept's easy again, because once you know an x-intercept happens to be the ordered pair 0, 0, then you already know that the y-intercept is 0, 0, so you don't even have to look for it. Okay, we might need some more points, but we'll come back to that if we do. Let's start our graph. Here's our y-intercept, our y-axis, and here is our x-axis. Some interesting numbers here. Well, we've got the 0 here. Let's put 14 out here and negative 14 out here. Okay, let's graph the x-intercepts. We have an x-intercept at 0, 0. We have another one at negative 14, 0, and another one at positive 14, 0. Remember, we have symmetry with respect to the y-axis from step 1. So we know that whatever happens on the left side is mirrored on the right side of the y-axis. We also know the ends are going to go down, so I already know that this comes down and this comes down. That tells me a lot. That's in behavior, step 4. Another thing I notice is that I'm supposed to get crossings at 14, but a kiss at 0. at the 0, 0 intercept. So what's going to happen is, and this isn't really accurate, but it'll do, we're going to go up, come down, kiss, turn around, come back up, and do the same picture on the other side because of the symmetry. So the picture is going to look approximately like this. I didn't even bother to find any more points because that was enough.